this is Eli. Welcome to another video. In this video, I'm going to talk about object-oriented programming. Object-oriented programming is also known as OOP, and it's really a paradigm shift away from an older way of programming called procedural programming. It has some benefits over procedural programming, especially in terms of when you're working with event-driven applications. Now, procedural programming is really designed around tasks. So programmers would design these programs around the tasks that need to be completed. And these tasks were performed in a linear or sequential order, one step after another, or one task after another. These tasks would be organized in blocks of code called routines or subroutines. So these subroutines or these blocks of code or even just a line of code would be executed from top to bottom, so in a top-down manner. Now here's an example of a procedural block of programming code that I pulled from the internet. So notice we have two subroutines here, one named do the work, and there's a bunch of lines. There's about 10 lines of code here, 9 or 10 lines of code. And then the other one is named print table. So we have two subroutines here. Now, do the work, it appears to be just moving some input, some part number information, some input into, or I should say some part information, input into a report. And this report is most likely going to be formatted in some way. So then at the end, we're going to perform another routine that's not really shown here on the screen, and that's called read a record. So we also have a routine named print table, and that's moving some part numbers to a report. And the part numbers appear to be indexed. So maybe this is this could be an array. But notice in the first subroutine, the very last line, perform read a record. We don't really see what read a record is doing, but what if we had these statements perform read a record in several subroutines in this program? So let's say we had, here we see two, let's say we had 100 different subroutines, and maybe 20 of them called that or performed that read a record routine. So now we would have to go into 20 different places. And if let's say we deleted the read a record subroutine, now we would have to go into 20 different places and remove that. Or for example, let's say this company, they decided to stop using part number and use some other identifier to identify the part. So you have to go all throughout the system and find part number and make those changes. So if this was a large system where you had part number used in a lot of different places in a lot of different programs, this would become difficult to maintain. So with procedural programming, like I just kind of showed you, you had some tasks that could be needed in several different places within an application. So let me show you what I mean here. For example, here's an example of a payroll program's tasks. This payroll program is going to calculate pay, determine overtime pay, determine deductions, and print a pay stub. Now let's say, for example, this payroll program is using an employee's social security number. Then the company decided we're no longer, for privacy reasons, we're no longer going to use the social security number. We're going to use an employee ID. So now imagine if we didn't just have determined deductions in one program. Let's say we had determined deductions in a lot of different programs. Maybe a couple different departments used it. A lot of different programs used it. Uh, it's not just used to determine a employee's pay, but it may be used in other places. So now you would have to go in and find everywhere a social security number was used and make changes. And if you had a very large, complex system, you could end up having to make changes uh, in lots of different places. And sometimes with procedural code, programs would be interrelated and interconnected. So maintenance would be difficult. So when you had to make changes, things would be easier to break. So some tests may be needed in several different places within an application. And as I just said, they could become interdependent, interconnected, and we call that spaghetti code because it would be difficult to maintain or change one thing without breaking something. So when we made changes, more testing would be required, and changes were more difficult to implement, and these systems were costly to maintain. So object-oriented programming is really a paradigm shift away from that way of designing software. Object-oriented programming is designed around classes. So data would be placed in, the data would actually be placed with the procedures and encapsulated inside of a class. So the data and the procedures would be organized together within a class. So these classes were designed around how the world works, how the real world works. So we might have an employee class. An employee would have data. An employee would have behaviors. So we might have an employee class, then we might have, for example, a department class. So classes would interact with each other. And you can consider classes to be relational. They have relationships. For example, you could have a parent-child relationship, and we call that inheritance. So object-oriented programs really adhere to four principles. And any language that's considered object-oriented would need to adhere to these four principles. And these four principles really are the foundation of object-oriented programming, and they really provide some benefits. For example, encapsulation allows objects to be self-contained, so making bug fixes and would be easier, and developing on a team, collaborative development is easier because you could give one person a class to develop and then maybe another person on the team a class. Then inheritance fosters reusability. And I just said you could have relationships between classes. So instead of coding um, a class all over again, you can just inherit from the existing class and then just reuse that code. And this really eliminates spaghetti code. Object-oriented programming also enhances productivity through reusable code. Encapsulation enhances security because code is hidden or encapsulated within a class. It also, we also have polymorphism that enhances flexibility. Thank you for joining me.